Greetings and welcome back. In this screencast, I want to do a couple of more examples just to illustrate the methods of solution, the algebraic methods of solution, so that you can see the patterns and structures and so you can see when to use what. Let's use some wisdom here. Let's imagine that we want to solve a system, and the system that we want to solve is 3x plus 4y equals negative 17, and 2x plus 3y is negative 13. We want to solve the system. There are three ways to solve the system. We can graph, we can use substitution, we can use elimination. To graph, we'd have to get y by itself in both cases, find the slopes and the y-intercepts, and graph the lines. That seems to be complicated. Getting y by itself on either of those lines seems to be more complicated than I want. Substitution works great if one of these equations is solved for x or for y. But again, that's not really happening here in any way that we think we can use. So we'll use elimination. And the way we're going to use elimination is we're going to try to make these two coefficients the same with opposite sign. So we think about a number that both 4 and 3 go into. We think 12. So we're going to try to make this 12, and we're going to try to make this negative 12, so that when we add straight down, those drop out. How do we make this 12? Well, we multiply by 3. Can't do that on one side without doing it on the other. How do we make this negative 12? Well, we multiply by negative 4. Can't do that on one side without doing it on the other. And so what does this turn into? Well, the first equation is 9x plus 12y is negative 51. And the second equation is negative 8x minus 12y is positive 52. And so we'll add the equations straight down. 9x minus 8x is 1x. 12y and a negative 12y add to 0. Negative 51 plus 52 is 1. And guess what? X is 1. Now, when we solve a system of equations, we get a point for an answer. This is not a point, that's an x-coordinate. So we plug back into either of the original equations. 3x plus 4y is negative 17. 3 plus 4y is negative 17. And then we use the algebra we know how to do. Subtract 3, divide by 4. And now we have an x-coordinate and a y-coordinate. We present them in alphabetical order. If we were to graph these two lines, as complicated as they are, we would get a point of intersection that has nice whole number coordinates. That's a coincidence, doesn't have to be that way, but in this case, it is true. I'll do one more just for fun. Let's do y equals 3x minus 1 and 3x plus 2y is 16? Yeah, 16. Sure. So this is a system of equations. This line's easy to graph. This one, not so much. But we notice that one of our equations is solved for y. This thing is y. And because this thing is y, it can replace y in any other equation. So 3x plus 2y is 16. Now we have one equation with one variable. The y's are gone. The y's are gone. Oh man, I did that on YouTube. Good Lord. Good Lord. But you can solve this using all the algebra you remember from when you were a kid, right? Almost out of space. Gonna bring it up here. Hopefully we know that x is 2. Hopefully we know that x is 2. That's great. And then when we want to find out what the y value is, well, we have this top equation already solved for y. So y is 3 times the x value minus 1, and that happens to be 5. So we present them in alphabetical order, x and then y. If we were to graph both of those lines, they would come together at the point 2, 5. They don't have to come together at a point with nice whole number coordinates. In this case, they do, because it makes the arithmetic easier in a screencast. Hopefully this is helpful, and it gives you a little bit of repetition to see, okay, I know what I think I'm doing. This lets you hit the questions that are on the Canvas page, so that you can say, oh, okay, I can do these things on my own. All good. Hope things are well with you. See you soon.